In this video, we're going to be looking at Boyle's law. And now this time we're going to be looking at volume and pressure relationships. So we want to be able to describe that relationship and then also given an initial volume or pressure, calculate the final volume or pressure of an ideal gas. So here's experimentally how one might look at the relationship between volume and pressure, where we have a fixed quantity of gas in a tube here. And in this experiment, this leg of the apparatus can be adjusted to change the pressure and volume of the gas. It's not so important. What is more important is the data you would get from such an experiment, shown in this table, where these are the pressures measured at several different volumes. And this is it plotted up in a graph here in the bottom. And from the graph, we can see that pressure is inversely proportional to volume. Okay? So similar to our last video and our video on proportionality, we can rewrite this as an equation. So we can say that pressure is equal to a proportionality constant K times 1 over the volume. Okay? Now I want to rearrange this equation a little bit. And what I'm going to say is that P times V is equal to K. All right? So I hope you see how I did that. And so what this means is for any given pressure and volume, if I multiply the two together, I should get the same value of K. And that's shown here experimentally. Within experimental error, all these values are essentially the same. So I can rewrite this then as P1 V1 is equal to P2 V2. Which again, for any given pressure volume, right, if I change the pressure and volume, the product of the two will be that constant K, roughly. And this is Boyle's law. Okay, and this is what we're going to be using to solve problems together. So let's do that. So a fixed quantity of gas in a flexible walled container is initially at 729 torr and a volume of 0.993 liters. The temperature is kept constant as the volume of the container is reduced to 0.720 liters. What is the resulting pressure at this volume? Okay, so similar to our last video, we want to be able to solve this equation for any variable. P1 V1 is equal to P2 V2. And so let's write down what we have first. So P1 V1, P2, V2, okay? So P1 here, the initial pressure is 729 torr, okay? And it has an initial volume of 0.993 liters. The temperature is kept constant. All right, as the volume of the container is reduced, so this is V2 now, to 0.720 liters, okay? And what is the resulting pressure? What is P2 at this volume? So we're looking for the variable P2. We have to get it by itself in the equation. So I'm just going to rewrite the equation here. So P1 V1 is equal to P2 V2, okay? So to get it by itself, all right, we can divide both sides by V2 or just bring V2 down here, okay? Either way, but I'll just do the divide both sides by V2 to illustrate what's going on here. You can do that little cross trick that I mentioned in the other video. But if we divide both sides by V2, V2 cancels on this side of the equation. And so we're left with P1 V1 over V2 is equal to P2. Okay? So again, you should practice solving for the different variables in this equation, similar to what we did for Charles' law. Okay, so now let's just plug everything in. So hopefully this is making sense. So 729 torr. And if it's not making sense, feel free to rewind the video or send me an email. Okay. So notice that the units of liters cancel and I'm left with torr. And when I do this, I get 1.00, let me write it a different way. Let me write it down here. Running out of room, 1.00 times 10 to the third torr. Okay, that's my answer. So let me just plug that in my calculator again. It's always good to just double check and see if your answer is making sense. So 729 times 0.993 divided by 0.700. Yep, that's what I'm getting. Okay, let's do one more example, I believe. So a gas sample occupies 5.24 liters at 776 torr. Find the volume of the gas if the pressure is changed to 856 torr. Okay, so let's again write our equation just so we're used to seeing it. P1 V1 is equal to P2 V2. Let's write down what we have. P1 V1 P2 V2. Okay, so P1, it initially is 776 torr, and the initial volume is 5.24 liters, right from here. And we want to find the volume, so I don't know V2, of the gas that the pressure is changed to 856 torr. So why don't you pause the video right now and try to do this on your own, and then we'll compare together and see if we got the same answer. Okay, so assuming you pause the video, the equation that you should have written down after you rearranged everything was this. So V2 is equal to P1 V1 over P2. And then when you plug all that into your calculator, you should get 776 torr times 5.24 liters over 856 torr equals, let me plug this in my calculator and see what I get. Hopefully we get the same answer. 776 times 5.24 divided by 856. I get 4.75 liters. Okay, so one more time, just check that. 5.24 divided by 856. Yep, 4.75 liters. So those are two examples of Boyle's law. There's plenty more examples in your homework. And in the next video, we're going to be talking about the combined gas law.